Welcome friends to the Gymkhana TV. Welcome to the paper of numerical method, which is the subject of engineering and science. Today I will explain our first module of the numerical method, which is introduction of the numerical method and the interpolation. See, numerical method. Numerical method is a part of mathematics, or you can say that numerical method is a part of applied mathematics. We can distribute or we can divide our mathematics into a two category. The first one is your pure mathematics and second one is your applied mathematics. In applied mathematics, numerical method is providing, and the numerical method provides such type of the formula to solve any kind of the problem. Before I start with our first module, there are so many questions which come to our mind is, what is the numerical method? What are the need of the numerical method? What are the characteristics of the numerical method? And what is it different from analytic method to the numerical method? There are such a bigger question. Whenever we start any kind of the subject, the first thing which come to our mind is why we need this subject. Here, dear friend, I will explain, and I would like to explain the purpose of the numerical method is, see, in this diagram I show that if we have a problem, the problem can be any kind of the problem. It can be any engineering problem, it can be any scientific problem, or it can be any business problem. So if we have a problem and we want to find the solution, so first we have to identify our problem. Then we have to identify of the roots of the problem. If we know about the roots of the problem, we apply the rule to convert our problem into a mathematical model. Once the mathematical model built up, then we have a number of methods to solve any kind of the mathematical model. And after that, applying the mathematical function or mathematical formula, we get the solution. So here, with the numerical method, we apply the numerical method on the problem to get the solution. And the problem can be any kind of the problem, but I will explain the such problem which contain the y is equals to f of x, or you can say that y is equals to f of x is a generalization equation for the numerical method. Here, y is equals to f of x. F of x is your function and y is depend on the x. So we can say that y is dependent variable and x is independent variable. If I change the x property, definitely I get the different kind of y. If I change the x property, if I change the situation where the function is live, definitely I get the different value of y. So whole thing is based on these two x and y variable, where one is dependent and another one is independent. For example, f of x. F of x can be any kind of the problem. Sometimes it is algebraic, sometimes it is system of linear equations, sometimes it is transcendental equation. Friend, if it is algebraic equation and I say that if f of x is a quadratic equation and we are very interested to get the root, so all of we know about how to solve the quadratic equation. Correct? If we solve this f of x with the quadratic method, we get the solution. But if f of x is behave like a cubic polynomial, again there is such a method to solve the cubic polynomial to get the root. If f of x is a higher polynomial equation, then this is more difficult to solve this f of x by the analytic function, analytic method. That's why we need the numerical method. Or you can take another example is, if f of x is from the transcendental equation, for example, my function contain the sine theta and cos theta value, then there is no such a method to solve this type of the equation by the analytic method. That's why we need the numerical method. There are number of the topic, there are range of the topic which contain the numerical method is. Before I go to the module, I would like to explain the definition of numerical method. See, numerical method is aimed at providing convenient method for obtaining the approximate solution of the problem. Previously I explained, if we have a problem and we identify with the problem, we can construct a mathematical model, and whenever we have a mathematical model, we apply such a formula to get the solution. Numerical method give that formula, and it also give the approximate answer of the problem. Here I am saying the approximate answer, not as an accurate answer, not as a correct answer, right? So now comes to our module. The first module which I explain in numerical method is introduction of the numerical method and interpolation. See, in this module we have number of the method. The first method is Newton backward interpolation method. Another one is Newton forward interpolation method. Third one is Lagrange's interpolation method, and the fourth one is Newton divide and difference interpolation method. Later on I will explain the interpolation. Now in your second module, which is your integration, and all of you know about the integration, it's what? It's the calculation of the area of the curve. Here in the numerical method we have two methods. First one is your trapezoidal rule to solve any kind of the integration, and the another one is Simpson's 1/3 rule. System of linear equation. When we have more than two algebraic or transcendental equations that comes throughout, that build a system, and the system is known as a system of linear equation, in which we have number of the method. The first one is Gauss elimination method, second one is matrix inversion method, third one is LU factorization method, and the fourth one is Gauss-Seidel method. Then we have an algebraic equation. In this algebraic equation we have bisection method, we have regular falsi method, and which is most important method is Newton-Raphson method. ODE, it's ordinary differential equation, and we have a formula, we have a method to solve any kind of the ordinary differential equation is Euler method, Runge-Kutta method, predictor-corrector method, and finite difference method. And the last but not the least is error. What is the error? I will explain later, but error play the very important role in the numerical analysis. So dear friend, these are the module. I explain each and every content of the module. In our second lecture I will start the first module, which is interpolation. Thank you so much.